Did you know that an auto-incrementing integer is not the only way to create a primary key value, and it may not even be the best way? In this video, I'll explain the pros and cons of auto-incrementing IDs, the different options you have, and why you might consider one of these other options. For so long, I've only ever used auto-incrementing ID values as primary keys in my tables. An auto-incrementing ID value is where you define a column as an integer data type and use one of the built-in database features to generate unique values for this number. Each new row will get a different ID. The first row could get the value of 1, the next row gets the value of 2, and so on. Depending on the database vendor, there are several ways to do this, such as using a sequence object or a special keyword inside the create table statement. Why would you use this approach? First, it's simple to use. There are features built into the database to generate the IDs. They can also be sorted. You might not actually write a query that orders by the primary key value, but when you create an index on this value, having sorted IDs makes it easier for the database to use the index. It also uses less storage. If you use a large integer data type, you're probably looking at 8 bytes per value. Now, these days, storage isn't usually an issue. With 1 million rows, an 8-byte primary key would take about 8 megabytes of storage. But then you have to think about the transfer of this information across the network and storing it in memory, so every little bit helps. So if this auto-incrementing integer value is easy to use and doesn't take a lot of storage, why wouldn't we use it? There are a few reasons. First, because it uses a predictable sequence, there can be a security risk as other people can guess the ID values. If you display the ID value in your application, then a user may be able to change this ID to see or edit data for another record. This depends on your application and other factors, but it's something to consider. Once you start to work with larger systems and databases, you may find that having the database generate the ID values is not an ideal approach. You may want to use the generated ID in the app, and you'll have to wait for the database to return it to the client. So given those disadvantages, what other options do we have? Well, there's a concept called UUID, which is an alternative to integers for primary key values. UUID stands for Universally Unique Identifier. It's a randomly generated alphanumeric value and is a good choice for primary key values. There are a few different types or variants of a UUID. Let's take a look at them and see how they are different. One of these is called UUID v4, which is essentially a random set of 122 bits and then 6 bits for identification. Here is an example of a UUID. There's a standard way of generating these values, so for practical purposes they are unique. Is it possible for a UUID to be generated that matches an existing value? Yes, it is possible, but it's widely considered to be close enough to 0 that it's worth the risk. So what are the advantages of using this UUID v4 for a primary key? It's considered to be more scalable as the generation of the UUID does not have to be done by the database. It could be, but it could also be done by client applications, so the applications don't have to wait for the database. It's easy to merge multiple databases. If you're merging one database with another, the records in two tables that are being merged may have the same primary keys if they are integers. This can take a bit of work to update the data to ensure the data is still correct. Using UUID values means there is almost zero chance of conflicts when merging. They are also hard to guess, meaning that if they are exposed to a client application, there's less risk of someone changing a value and seeing data they shouldn't. So what are the cons? They take a bit more storage than integers. Some databases can store these UUID values as 16-byte numbers rather than 36-byte text values, which can help, but they still take a little more storage than integers. This may not be an issue for you and your database, or it could be something to consider. Also, because the keys are larger values, they may take more time to compare when running queries. This may be something to measure and could depend on your database vendor. Finally, because the values are random, they aren't generated in any order. This means that indexes on this field can be less effective or take longer to update compared to using an ordered ID such as an auto-incrementing integer. I'll show you how we can generate and store a UUID value in SQL later in this video. There is another type of UUID though. Another variant of UUID is UUID v7. This is similar to UUID v4 in that it uses a randomly generated value, but it includes a component of the time at the start. This means they can be sorted and better used in indexes. Here is what a UUID v7 value looks like. The pros of the UUID v7 are similar to UUID v4. It's more scalable as it can be generated in many places. It's easier to merge databases. They are hard to guess. Also, because they include the time component, they can be sorted for an index, which improves performance compared to UUID v4. The cons for UUID v7 are similar to UUID v4. They use a little more storage than integers, but as mentioned earlier, that may not be an issue for you. The performance may not be as good as integers because of this size, but it's something to measure. Another type of UUID is something called a ULID, which stands for Universally Unique Lexicographically Sortable Identifier. Yes, I know that's more words than is included in the acronym, but that's what it is. A ULID is similar to UUID v7 as it is also sorted, but it's more compact so takes less storage. Another type is called a Snowflake ID. This is similar to other UUID types and it includes extra information like a machine ID and a sequence number, which can help with uniqueness. It's also smaller than the other UUID types. This is all good to know, but how do we use them in our database tables? I'll show you this example for Postgres and then explain how they are different in other vendors. To use an auto-increment ID in Postgres, you can use either a serial data type, a sequence object, or an identity column. This first query shows how to use a serial data type for an ID column. We saw this earlier when we used the serial data type and then inserted these values. The second method is using a sequence, which can be done by creating a separate object called a sequence, like this. We have a table that is created with the ID value that has an integer data type. Then, when we insert a value into the table, we call the sequence and get the next value. The third option is to use an identity column, which can be defined when you create the table. Just like the serial data type, a new value is generated when you insert a row into the table. What about UUID values? Postgres has a data type called UUID, which is specifically designed to store UUID values. They are stored as a number rather than a text value that they look like. To use this, we first create a table that uses this UUID data type. With the table created, we can insert a row into the table. We can use a function called genRandomUUID to generate a UUID value. According to Postgres, this generates a UUID v4 value and is the most common type and appropriate for most applications. We can insert a row using this function for the UUID. Then we can select from the table and see our UUID value here. So that's how it's done in Postgres. What about other database vendors? This table shows what data type can be used for each vendor to store UUID values and how to generate them. Generally, it's better to store the UUID value in a binary data type rather than a string, as it will take less storage and perform better. So now we've learned about the different types of UUIDs and how they compare to the auto-incrementing integers. Which type should you use? Well, it depends. It's probably not the answer you want to hear, but there's no one right answer in my opinion. It depends on your requirements, the size of your application, and what's important for you and your team. During my research, some people said that auto-incrementing IDs are suitable for most applications until you need to start thinking about scaling them. Other responses said that UUID v7 was most appropriate as it has a lot of the advantages and minimal disadvantages. One suggestion I've seen is using both, using an integer for the primary key and foreign keys so tables can be related, and using an externally focused UUID for any APIs and applications. It adds complexity, but it could also be useful to you. While the choice of integer and UUID depends on a few factors, there are many other techniques and approaches that I can actually recommend. You'll want to watch this video next where I distill my 20 years of working with SQL into 11 minutes of practical tips. Thanks for watching.